Well, bum 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 bum. Here we are, part 5. You've done it again. We're finishing chapter 7. Great job if you've been using this video series to learn and study for the ISC2 Certified in Cybersecurity certification. Also, remember, I've got additional content. You can reach out to me through a comment and ask me for that. I've got a textbook that I've written that coincides with this, and I want to share that with the world as well. So let's cover part 5, where we jump into network security, and then we'll just do a quick conclusion as to what we covered in this chapter. So this is the key, right? This could be the network administrator's job. This could be another operations center's job. A lot of times found within a security operations center, monitoring that network, using Wireshark to do, manual checks of traffic, troubleshooting, finding that we get an alert and we need to, look into that deeper. Okay. So measures to prevent and monitor misuse of modification of network accessible resources. So remember that man in the middle attack, right? Within a network. So, essential for detecting, preventing, and responding to cyber threats. It could be that a great organization quickly realized that in their patch management, they put in that CrowdStrike patch that caused the system to go down, right? So through their network security principles, they were able to see what was going on prior to that endpoint going down, that Windows endpoint going down. So let's start with design and architecture. Hugely important. Strategies here really revolve around network segmentation. So taking that large network and segmenting it into more manageable areas, okay? And that starts with a demilitarized zone, which is a subnet that exposes an organization's external-facing services. These could be email servers, right, that need to have access to the web to share emails among other email services. This can be web servers. They can be application servers, etc., that we want to isolate from the internal network. So we build a separate network. We add an additional layer of firewall, okay, and other detection so that we know that the data from those servers in the DMZ are only going to reach servers on the most limited basis into our network. So we're protecting the rest of our network by segmenting it and adding a DMZ, okay? We can create VLANs, or virtual local area networks. So this is where you might actually see this depending on your router at home. For example, the most basic implication of this, okay, is the idea of having 2 networks on your Wi-Fi. With a modern Wi-Fi router, you get the opportunity to turn on a guest network. And again, anyone you don't trust, as well as your kids, should be on that guest network. Your IoT devices, which are highly insecure, should be on that guest network. Yes, this means that you might have to change your phone over there if you want to manage or add or delete or update things, but it keeps those vulnerable endpoints off of your primary or trusted network. In an organization, we might create VLANs for departments if they're large enough. We definitely might create a VLAN for the finance department that separates it from the rest of the network so that we better secure that finance data. Okay, so just a few things to think about. Additional aspects, utilizing those virtual private networks. So, having those encrypted ability to remote into the network to gain access to become part of that network. And in that process, that means that a client may be tested through network access control before being authenticated into the network to know that that client operating system or endpoint has the latest patches, is up to date, maybe even a quick scan for viruses, etc. So pretty important. Now we take this to a whole new level that, again, we're just hitting the surface of zero trust here. There are books that you should read on zero trust, and I'm going to introduce you to my favorite when we hit that topic. But micro segmentation, taking this segmentation to a whole new level, that instead of just segmenting networks into virtual local area networks, into VLANs, we literally segment down to the endpoint device. Okay, it becomes its own, and then we manage all of the traffic and where it can access, versus having access to many servers. It would just, that endpoint would only have access to servers, to data that are needed to do that job. So that brings us to, WLANs, right? Wired local area networks. So of course, this adds a whole new aspect. We're no longer securing the network via physical connections, right? That have to be, spliced for a man-in-the-middle attack. But we're talking about, expanding our network wirelessly. Suddenly it hits the parking lot. It hits a block down if we got powerful equipment, opening up a whole new attack vector, right? So think of this again, from a wireless standpoint. And VLANs, this is like having a modern router where you have the ability to create separate wireless local area networks, i.e. VLANs, for a trusted network and for a guest network. So at home, if you have kids at home, you put their phones, because they'll download anything, on the guest network. You put your IoT devices on the guest network, thus creating a VLAN that segments that network for unsecure devices from your secure devices, from the devices that you do online shopping with, that you check your investments with, all of those type of things, as a simple home example, if you will. So, when we talk about security infrastructure for the ISC2 exam, you're going to need to be familiar that we're back to that physical protection of the network. We need to know we have ample power. We need to know we have backup power. We have a few data centers in Prineville, Oregon, close to where I live. Those data centers, like the Apple data center, right, or the Facebook data center, they have backup power in the way of battery banks, and then they even have backup to the backup power, okay, which means they have generators, these big 5 megawatt generators that will kick off if the battery power gets down low enough, right? Because today, typical power outages are a short period of time, if you will, okay? So those battery backups, just like one that you might have at home, keeps that computer running so you can gracefully shut it down, or in the case of data centers, keep things running, okay? What you will need to know is power. You'll need to know data centers and closets to protect that physical network, right? Protecting the equipment, as we talked about already in physical security, how HVAC and cooling, and heating at times plays in, fire suppression, detection is important, okay? Agreements like MOUs and MOAs, which are, MOUs are Memorandum of Understanding, and MOAs are Memorandum of Agreement. So, when your data is in the cloud, what is it that you're responsible for? What is it that the cloud provider is responsible for example? And these can also play down to vendors that come in and, do the work as professionals in maintaining your fire suppression system. So you'll definitely need to know some of these classifications, focusing on Class C. Keep in mind that a lot of times these are multi-class extinguishers when we're talking about physical extinguishers, that will do multiple fire types, okay? But again, specialized agents, we're going to focus on Class C fires with minimal equipment damage. So we want to put out the electrical fire, but not completely damage the equipment, okay, to where it can't be used again, like water on electrical equipment. Forget it, right? Early detection, again, hugely important. Keep those incidents to a minimum. Firewalls within buildings so that they don't spread across, etc., right? One of the reasons why racks of computers are racks, that have a limited number of servers in them, versus a rack of a row where a fire could spread to the next column of servers, if you will, okay? So security controls, well, those are, we've already talked about a lot of these from a logical control standpoint, and authentication and authentication and authorization. Now, we're talking network wide. So firewalls, intrusion detection, which we'll get into. Air gapping is a good practice. The example that I'll give you there is, currently there is some software, okay, ransomware that's targeting end users. It's like Nibbernet or something like that. Anyway, it's targeting end users. Your computer at home that you download and click on the wrong link, they install the ransomware, they encrypt your data, and they want, four-figure, a couple $1,000 for you to get all your data back. And that may be pictures of kids and videos and things that you might be willing to pay to get back, right? Well, in my case, what I do at home, not as easy, let me be clear, in, larger networks, but is air gapping. So after the night that my backups run, because I, back up regularly certain things, but then I do full backups. And when those full backups are done, well, I disconnect my network attached storage unit so that if I happen to download some ransomware, that NAS isn't on the network, and thus I'm able to restore from that, okay? Again, these are things like in the CrowdStrike, those companies like Delta should have been able to re-image those computers with, master images and get systems back up quickly, not be down for days because of one patch, okay? So in addition, we have layered defense. So we're not going to just defend at one layer, say of the OSI model as we see in Defense in Depth. So these work, simultaneously, if you will. We might start with a firewall to protect the perimeter, software firewalls on endpoints, intrusion detection systems inside our networks, antivirus on endpoints within our network, etc. All of it together, integrating people, technology, operations, policies, practices, frameworks. It all works in Defense in Depth. Okay, so on to a few more security tools. Of course, we've talked enough about firewalls, but let's talk IPS, IDS, XYZ, and PDQ. So intrusion prevention systems detect and prevent vulnerabilities. Now, the more a system does, the more weight per se that it puts on a network. The more traffic it puts on the network, the more traffic and time it takes in analyzing and thus removing, potential vulnerabilities. So downscale that a little bit. We have intrusion detection that basically will monitor the network traffic and let us know about suspicious activity. So then we can then use tools like Wireshark, use Wireshark to analyze the traffic and see, is it really, a threat? Is it really a hack? Is it really malicious software, or is it just something abnormal from the baseline? Here's that term again, the baseline network traffic that we see when we know everything was well and protected. So a couple types of IDS systems: host-based IDS, network IDS. Again, they all work together. And a lot of times, like in my small business Meraki equipment, this is built in. So these services come built in a lot. Do know and learn how to use Wireshark. There's some great videos out by David Bombal and one of his associates who is like the Wireshark guru. So take those classes, spend hours, learn network analyzers, run them on your own network so you know what's going on and what traffic is going in and out of, say, your home network. Again, I can't stress enough, build your home network, build it big, have it be a small business network, have that as a portfolio to share with potential employers, but more importantly, do the hands-on work like my students get in this class to take this knowledge that you'll need for the ISC2 and turn it into a skill set, which is what employers want. Okay, employers want knowledge, but they want the skills as well. Learn ZenMap. You'll find that in Kali Linux. That's a graphical user interface of the Nmap tool. Of course, Nmap itself is going to be more efficient in the command line interface. That brings us to network monitoring and analysis. This is where we're monitoring that traffic. Again, let me be clear, right? a lot of terms being thrown around here. Know the terms and know what they do. But, SIEM, so provides real-time analysis of security alerts. So this is a system up and above the IDS. What is that analysis? Do we see a signature that indicates a typical malware, a typical breach, etc.? I don't know why I couldn't remember breach this whole lecture, but whatever. Network monitoring, right? Continuous observation, so automating that process. AI is coming in to help better monitor networks, to create a better baseline so that, if we took a baseline when there was, say, an advanced persistent threat going on, we'd never know it existed because it's in our baseline, right? All of this stuff tends to happen within a SOC, within a security operations center. That may be one person, that may be a whole team, okay? Especially in data centers. We have huge security operations centers with people that are responsible for monitoring and securing just one small aspect of the network, okay? And so that team is made up, of analysts who analyze, who do the work. Part of that team is going to be red team. Part of it will be blue team. I always remember red as offensive. Okay, so those are the attackers. This works great to secure your network because you have people you trust, ethical hackers that are hacking in, trying to break in, trying to steal data, trying to find the vulnerabilities. So then the blue team, who is defending the network with their existing technologies, which may work today, but may become a vulnerability tomorrow, right? In the case of CrowdStrike, sorry CrowdStrike, but you kind of deserve this one. They work together to better secure the network. Okay, so you got a team that's hacking the network and a team that's defending. And when we do find those vulnerabilities that the blue team has not secured, we can quickly secure those and further exemplify the security of our network. So just a few more terms to know here. Access control list we've talked about. What is an event, right? It's an observable occurrence in a network or system. It's that abnormality. It's something that leads to us doing more information, seeing if it's just, a patch that's different, that set off an alert or whatever, okay? Looking at logs, seeing abnormalities, anomalies in logs. So here's a log that logs on a regular basis and suddenly there's 5 minutes missing. We can go to that secure backup log, right, that's encrypted that hopefully the hacker couldn't get into as well, and look at what really happened at that time. Auditing, you hear me talk about it all the time. Audit, audit, audit. You want to audit your resume, make sure it's right before you send it out. You want to audit your network. You want to audit your principles, your policies, etc. Finally, ingress and egress. These are really easy to remember. Ingress is monitoring incoming traffic. And then if you just memorize that, egress is monitoring outgoing traffic. So some of these systems do both, some only do one. So again, the more systems we have that are doing detection, the more weight and we're putting on our network, thus slowing down the network connectivity that is used for productivity, that's used for business, it's used for data transfer. Okay, so it's all a balance, just like balancing physical security, logical security versus, allowing users to do the job they need to do in an efficient amount of time. So finally, I do encourage you, I'm not going to go through this in detail. I do encourage you, look through this, pause this video, look at the terms, look at the best practices. Can you define what endpoint security is? Do you understand different user account levels, what a firewall is? If not, go back and learn. I encourage you to use large language models. You can go out and say to Google, what is, my phone's probably going to go off. What is a DMZ? And it will dive you rabbit hole deep into learning what a DMZ is. So remember, AI is used to learn, not to earn. So don't use it to do your homework. The only person you're affecting is yourself. Well, actually, and then if you get a good grade, and other people actually did the work. That's really unethical. And in this field, folks, we have to be at our highest ethical levels because we have access, we have the keys to the kingdom. So a few more terms here to go through. You know, a nice little graphic. Notice the SOC team working together with all these different best practices, technologies, firewalls, antivirus, etc., to secure the network and secure the endpoints. So that leaves us here with, you as a cybersecurity professional. You need to understand applications. You need to apply a framework. Again, I suggest starting with Christian Espinoza's simple framework. That's 85%. If you're doing that at 100% level, you're protecting 85% of your network, okay? Which is more than a lot of small businesses do these days. So, understand design, understand segmentation and implementation and managing all this stuff, understanding tools that can be used to help you automate, such as patch management, but know how to use patch management so you're not patching all of your systems and performing a CrowdStrike incident, if you will, okay? We use all of this to build a better, more efficient, faster digital world. And every day we're sharing more and more data on our network, on the internet. And with that comes more reason for unethical hackers to gain access to our network to steal data. Let me know if you have any questions. Folks, please let me know. Please comment below. Please subscribe. I'm on a professor's salary. It helps a little bit. Okay, so do your part. I'm creating hours worth of video that I want to share my knowledge and my passion for cybersecurity. Most importantly, reach out and comment on things that I can improve to make these videos more helpful to you as you begin your cybersecurity career. Take care and have a great day.